Let's look at vertical transformation, vertical stretching, compression, horizontal flipping. Now next we consider the function f of x. And what occurs when we consider the function g of x, which is c times f of x, where c is greater than 0, or c is between 0 and 1, or c is less than -1, c is between -1 and 0, c is -1. Okay, so various values for c. Again, notice that the way this is written right now, g is written as a function of x, of f of x, sorry. So it's written in terms of another function, f of x. Great. So again, we have the absolute value of x, my function. What is a graph of? And notice what I'm about to do. I'm going to multiply f of x by 0.5. So if you recall, let's get a few points here. This is -2. Here is 2. And that produced, in both cases, a 2. So then doing this is pretty straightforward for this graph. The absolute value of -3 is 3. Absolute value of -2 is 2. The absolute value of 0 is 0. The absolute value of 2 is positive 2 is 2. -2. And 3 is 3. Great. You can see this is not a one-to-one function. And what am I doing? It says take the output. Again, remember, f of x, this whole symbol is my output together. And it says take the output and multiply it by 5. So the reality is, what it's saying is, here's my output, multiply that by 0.5. So -3, it produces a 3. Divide that by half. I'm going to just write it in exact form. Half of 3 is 3/2, which in decimal form is 1.5. Also exact. -2, output is 2. Multiply that by half, and I get 1. 0 produces 0 when I put it in here, but when I multiply it by 0.5, I get a 0. 2. The absolute value of 2 is 2. And then multiply that by a half, and I get 1. Finally, enter 3, and same thing happens. I multiply that by, the output is a 3, multiply that by a half, and I get 1.5. So again, now if I were to graph this, what has just happened? Well, no, 0 has stayed exactly put. -2 has shifted to 1. Positive 2 has also shifted to 1. 3, which used to be produce 3, is now 1.5. So here is 1. 1.5 is right there. Positive 3 also now produced 1.5, which is sitting right there. So now if I were to graph, I get this little picture. So how to interpret this? Well, it looks like this has been compressed by a factor of 1/2, 4.5. In other words, imagine what you're looking at now is here is the original, and I've compressed this vertically. So now it's taking up half of what it used to take up. Okay, so it's been squished down by a factor of 0.5 or half. Okay, so that's the result of doing this. So let's look at another function and repeat this. Consider the graph of f of x equals square root of x. So again, grabbing a few values. At 0, it's 0. At 4 is 2. At 9, square root of 9 is 3. So what is happening now? What it's saying is, take again, these x values are going to stay exactly the same. But now I'm going to multiply every single output by 2. Enter 0, you get 0. Double that, you still get 0. 4 produces 2. All right, so enter 4 in here. So again, let me make sure you see what's happening. Enter 4. Let's put emphasis here. That produces square root of 4 is a 2. 2 times 2 is a 4. So this produces a 4. 9 produces 3. Double that, it produces 6. So now 0 stays at 0. 4 has now doubled to 4. 3, which, I'm sorry, 9, is pretty confident about right there, has now gone all the way to 6, which is way up here. Okay. So if I were to graph this, it looks something like this. So it looks like now, instead of compressing, what we've done is stretch this thing. We've stretched it by double its amount. Okay. So what has happened? The result is that f of x has been vertically compressed, stretched. By a factor of 2. So in the first one, this is being, again, vertically compressed by a factor of a half. But this one, when I multiply by 2, well, it gets vertically stretched by a factor of 2. So notice we start off with a value that was between 0 and 1. So here in this case, when we look at the general statement, g of x is equal to c times f of x. In this first case, we use c, so that it's between 0 and 1. And this one, my c is greater than 1. And it seems to have been stretched. So come back here and just verify using Desmos. So my function here is now the square root function. So I'm going to type over here again, f of x equals square root sqrt x, and there's my function. And now what you can do is this, just come over here. You can even continue using function notation. I'm going to use it exactly the way it's written here. G of x is now 0.5 of what? f of x. Oops, there we go. And there you have it. You see that now the black one is the original function. This red one is the new function. And you can see that 4, it used to be 2. And now it's at 2. It's half of what it used to be. Sorry, at 1. So at 4 it used to be 2. Now it's at 1. And the other value, for example, here's 9. Square root of 9 is 3. And now it's half of that amount. We'll come back over. So you see that 1, 2, 3, 4, 5. So at 9, it is about 1.5. It used to be 3. So again, it's been compressed by a factor of a half. What about this equation? Consider, again, the same function, f of x equals square root of x. What is the graph of h of x? Where I'm multiplying by -1, or just take the opposite of f of x, either one. These are two different operations. One's multiplied by -1. Let's just find the opposite of everything. So we're again created a little table just to verify what I'm about to do. I still have these values as well. Original 0 is 0, 4 is 2, 9 is 3. Now, what does this say to do? Again, using these same inputs, it says multiply the output. Again, this is my output by -1. So take my output and multiply that by -1. So 0 produces 0. Multiply that by -1. It's still a 0. 4, multiply that. So 4 into 4, I get 2. And then multiply that by -1, it gives me -2. Square root of 9 is 3. And then multiply that by -1, it gives me -3. So what is the result? All right, so I got 0, 0. I got 2 is now a, sorry, I got 4 is now a -2. And 9, which again is not sitting here, it gives me a 3. So it looks like, from the graph this, I'm going to figure out what 9's about right here. Kind of create some curvature to this thing. You get the following curve. So what does it look like multiplying by -1 did? It appears this h of x is f of x flipped across horizontal axis. So again, here's my horizontal axis, which is just, well, if this is x and this is y, this is the x-axis. So it looks like all I've done is take every single point and flipped it across this axis and creating a mirror image. So it's created a mirror image. Across the x-axis or horizontal axis. And we can verify it again in Desmos. And you should do that. You can write different functions and see what happens. So here, all I'm going to do is, again, I'm going to find just a negative of it. If I do that, boom, there it is. It's taken the first graph, which is square root of x. And now when I find out the opposite of f of x, I get this flip across this axis. You can see the symmetry. So it's perfectly been flipped, just a mirror image on the cross the horizontal axis. Okay, so now we have kind of these three examples. It looks like if I multiply by a number between 0 and 1, it compresses. If c is greater than 1, it stretches vertically. All this so compresses vertically, stretches vertically. And if I multiply by a -1 or just take the opposite, it flips it across the x-axis. Okay. Now, so let's look at this example. Example A, consider the function again, square root of x. What is the graph of h of x equals -2f of x? So now we're asking the question, okay, so what does this do? So we notice that this value, the c now, is between 0 and, nope, sorry, not between 0 and -1, but less than -1. So c is less than -1. So I can break it down into two parts if I sort of wanted to do it. There is a stretch of 2 and a flip of 1. So in other words, I can think of this as the following. -1 times 2 times f of x. So I can apply each one separately, or now that I realize that this is a stretching and this is a flip, I know that what's going to happen is this value is going to double. So what used to be 4 is 2, now it's going to be 4. Right, so this point being 2, no, sorry, 4, 2. Get that backward. So at 4, I get 2. But now at 4, I'm going to double that and get 4 back out. At 1, this produces 1. But at 1 now, I take this output, it gets flipped and doubled. So now it's going to produce a -2. So the result, there's two things that happen here. I am flipping across the horizontal axis and also stretching by a factor of 2. So there's two things that that action did. Flipped across x-axis or horizontal. Sorry. That's one. And secondly, stretched by a factor of 2. Vertically stretched. So again, when you describe it, make sure you have the direction also. That's important. Vertical stretch by a factor of 2. So given the function f of x, the function g of x is equals c f of x, where c is greater than 1, is the function of f of x transformed by, again, c is greater than 1, so it's vertically stretched by a factor of c. Given the function f of x, the function of c f of x, where again now it's between 0 and 1, is the function of f of x transformed by vertically compressing by a factor of half, or sorry, by a factor of c. So again, the factors means you're going to multiply to get the final result. Given the function f of x, the function of g of x, which equals -1 times f of x, or just the opposite of f of x, is a function of f of x transformed by, again, flipping across the x-axis or horizontal axis. Okay. And again, think of it creating a mirror image across the horizontal axis for this last one. The vertical stretching and compression follow the same rules when, again, C is less than 1 and C is between -1 and 0. So again, this is compress and stretch. Of course, and also flip. Both require the flip part across x-axis. So let's look at this last example. Write down the equation shown. I'll show function in graph form. Okay. So what do we have here? It looks like this is definitely looks like the absolute value. So the basic function looks at absolute value. To kind of identify what am I looking at? And so that one is going to be y equals absolute value of x. That seems right. And what am I also looking at here? Well, it looks skinnier, right, than the one before. Well, the other one, here's 1, here is -1, here's 1. So the original one looks like this, where the -1 produces 1, -1 produces 1. So it looks, and 2 produces 2, for example, and so on. And -2 produces 2 as well. But now it seems like it's skinnier. Well, what's one way that can happen? If I were to stretch it vertically, pull it, all of a sudden this graph will look skinnier. So I just got to figure out, okay, so if that's what's happened, for example, where has this point here, -1, 1 gone? So before, at -1, I got 1. Where is that now? Well, I'm still at -1, but where is it? So I'm going to come down here until I find this. And it looks like it wound up at 3. What about the other one? Here's -1. Sorry, here's +1 is 1. Where is it going now? If I follow this down, it's like, yep, it's still at 3. So -1 is produces 1, but now it's gone to 3. Also, 1 used to be 1, now 1 is at 3 as well. So again, it looks, since we talked about multiplying, it looks like maybe we've taken this and multiplied it by 3. Let's just verify something. I also get the point -2, 2. Where is that now? Well, -2 now, where's that going? So that's -2 here, -4. It looks like I can't see it, but it's pretty far down there. I'm going to guess that, yeah, it seems like it most likely had gone to probably 6. So, what am I thinking about? So this is about multiplying. It looks like I took 1 and multiplied by 3, 1 multiplied by 3. If I take 2 multiplied by 3, I get 6, and that seems about right where this is headed. So I'm going to say that, write down the equation shown on the graph. It looks like what I've done is taken the old function and multiplied it by not 2, but by -3. So I take the old function, multiply it by -3, and that produces this g of x. So here's my g of x. And this is the original, which I'm going to call f of x. So to do this question, notice I had to sort of understand what maybe the basic function looked like, and then after that, I can determine what this new function is. So notice there was no real solving taking place per se of moving an equation. I'm trying to understand how the transformations work, and this allows me to then write a new equation. So it looks like if I were to actually write the equation, it would look like this. And we know that f of x is just going to be the absolute value. So this function, g of x, is just -3 times the absolute value of x. And this is assuming that this original one here is f of x, which equals absolute value of x